Hey guys, in this video, we are going to review all the exponent rules we've learned so far and fill out the graphic organizer together so that you have all the rules in one place with accurate examples. Let's start with the zero exponent rule. Remember that anything to the power of 0 is 1. So x to the power of 0 is 1. 12 to the power of 0, also 1. Now 5x to the power of 0, the only value that has the power of 0 is the x. 5 is actually to the power of 1 because there is no exponent there, so you could see that 5 is to the power of 1. So this is actually 5 times 1, since x to the 0 is 1. So 5 times 1, which is 5. Now with that same knowledge, in the next example, only n is being raised to the power of 0. So this is the same as negative 2 to the third power multiplying to 1, which is the same as negative 2 to the third power, which is negative 8. The next rule we're going to discuss is the negative exponents rule. The negative exponents rule, if you see a negative exponent, that is the reciprocal of its positive counterpart. So x to the negative a equals 1 over x to the a. This also works in the opposite direction as well. If you have 1 over x to the negative a, so now your negative exponent is in the bottom, that's the same as x to the positive a. So if you want to change the sign, cross the line. Meaning, if you want to change the sign of an exponent, cross the fraction bar line. That will change the sign of the exponent. We always want our exponents to be positive because our exponents tell us how many times to multiply that base to himself, and I can't have a teller that's negative. That's why we always leave our answers in positive format. And again, it's sign of an exponent, only the exponent. So 3 to the negative 2, that's 1 over 3 to the second, or 1 over 9. A to the negative 7, that's 1 over a to the 7th power. But p to the 4th, q to the negative 1, only q has a negative exponent. So p to the 4th remains where it's located, and q to the 1st relocates to the denominator. The next thing we did was we added and subtracted monomials. Adding and subtracting monomials is simply combining like terms. Do not change the common variables and the exponents. You should not be touching exponents if you are simply adding and subtracting, because all adding and subtracting is combining like terms. So, for example, 10x plus 3x is simply 13x. And the thought process is you're basically adding 10 and 3 and holding the x. You're figuring out how many x's you have. So if you have 10x here plus 3x here, 10 plus 3 is 13x. There's 13 x's in total. For the next example, you have negative 2k squared and plus 6k squared. So that's going to be 7k plus 4k squared. 4 is what you're thinking about, negative 2 plus 6, when you're combining those two like terms. And the last example, these are like terms, so we're thinking about negative 5 minus 4, which is negative 9m squared n. So it's very important that you remember that when you are adding and subtracting, you do not change, do not touch variables and exponents. You're simply thinking about adding their coefficients. Our next rule is our product rule. And the product rule is used when you see multiplication of bases. So multiplication of bases. And the way we multiply bases is we keep the base, assuming the bases are the same, of course, keep the base, add the exponents. So this is the product rule, and it's for multiplication of bases. So x to the a times x to the b, they do have the same base, so we keep the base and add the exponents. 9 to the 5th times 9 to the 7th, keep the base, add the exponents. Keep in mind that that's not going to be 81 because these are not really 9s. They are different numbers than 9. Next, we have a to the 7th times a to the negative 1 times b to the 3rd times b to the negative 5. So our a term is going to be a to the 7 plus negative 1, and that's going to multiply to our b term, which will be b to the 3 plus negative 5. For a final answer of a to the 6 and b to the negative 2, fully fixed to be a to the 6 over b squared, because we cannot leave negative exponents. Last question, we have numbers and letters, and these numbers are just plain numbers. Unlike the first example, these were not plain 9s. These were these were base 9s, so they're like 9 to the 5th, which is something massive, and 9 to the 7th, which is something massive, right? But that's just a plain negative 2, and that's just a plain 9, so that's going to be a plain negative 18. Keep the base, add the exponents for x, multiplying, and keep the base, add the exponents for y, multiplying. Next is our quotient rule. And our quotient rule is used when you see a division of powers. So you see powered numbers or base numbers, base and exponents, dividing, or one over the other. Okay? And when you have base numbers, like x to the a, or powered numbers, x to the a over x to the b, when they're dividing, to simplify them, that is, keeping the base and subtracting the exponents, because division makes things smaller. So when you divide something, it makes it smaller in value, assuming that the top is larger, okay? So keep the base and subtract the exponents. So the rule is x to the a over x to the b is x to the a minus b. So some examples, negative 2 to the 20th divided by or over negative 2 to the 5th is, keep it in parentheses, negative 2 to the 15, which comes from 20 minus 5. In this next example, x to the 12 over x to the 3rd is x to the 12 minus 3, which is x to the 9th. Now, if we have more than one variable, here we have r's and here we have s's, we're going to just do the quotient rule twice, once for the r's and once for the s's. So for the r's, we have r to the 2 minus 2, and for the s's, we have s to the 2 minus 3. So that's going to be r to the 0 and s to the negative 1. R to the 0 is 1, and s to the negative 1 is 1 over s to the first power. And lastly, we have coefficients of 28 over 4, and then we have m's. So let's take care of the plain numbers first. They are plain numbers, so we could just do 28 over 4 to get 7. And the m's are going to be m to the 5 minus 3. So a final answer of 7m squared. Our last rule was our power rule. And that is when you have a based number that has an exponent, like let's say x to the 3rd, and you're raising it to another exponent, like raising an x to the 3rd to the 4th power. When you do that, the exponents multiply to each other, okay? Because you're making 4 x to the 3rds, right? Because this is telling you to multiply this guy to himself 4 times, so it gets even larger. It multiplies out into more values. So x to the a raised to the b is x to the a times b. Now keep in mind that everybody inside the parentheses is getting that power. So we'll deal with that when we handle this last example. So here we have 7 squared being raised to the 9th power. That's going to result in a 7 to the 18th power, which is 9 times 2. In this next example, we have w to the 4th being raised to the 3rd power. That's going to result in w to the 12th power, 4 times 3. Now in this last example, this parentheses has multiple items inside of it, and that is a monomial inside of it. So every term in that, or every piece of that monomial is going to be squared. including the -4, the r, and the s. So 1 by 1, that's going to result in -4 squared, r to the 3 times 2, because when you go to square r to the 3rd, it already has an exponent. So when an exponent meets another exponent, they multiply. And s to the 7 times 2. To make a final answer of -4 squared is 16, because that's -4 times -4, r to the 6th, s to the 14th power. That concludes all the rules, and you have now a perfectly completed graphic organizer that you can use for your quiz and your upcoming test. Thanks for watching.